In this video, we're going to talk about the higher derivatives of a function and the chain rule. So the first thing that I'm going to talk about is going to be the higher derivatives. So you have f is a differentiable function. You see that the derivative of f turned out to be a function in x as well. So you have f and you have f prime. Okay, so this guy is also a function. Okay, so this guy is also a function. So it will be making sense if you differentiate this guy again. So you can differentiate this guy again. So when you differentiate this guy again, you get the derivative. Another derivative is turned out to be derivative of f prime. So this thing in notation, we're going to write f double prime. Okay, and this guy is called second derivative. So for the thing that we have the second derivative of f turned out to be, we just differentiate the function f twice, okay? And we have two notation. The notation that we have is going to be f, and you see that we're going to have the psi prime. So this guy is called f double prime. So this guy is called double prime. Okay, so this guy is called double prime. So these two notation here are the same. Okay, they are called double prime. And we can have the Leibniz notation. So this guy is d2y dx square. So this one is going to be, some people read d2y dx square, or you can just read d square. Okay, so this one read. Okay, so it is read d square y dx square dx square. Okay, so it's read d square y dx square. Okay, so this one is going to be stand for the second derivative of a function f. Okay, we also be able to compute the third, the fourth, or any higher derivative of s by differentiating the function f 3 times, 4 times, and any time respectively. And we're gonna write f to the nx for the nth derivative of the function f. Okay, so this one is gonna be the n derivative, and you'll be able to write this thing as the Leibniz notation. So you may write dny dx to the n like this. So it's gonna be the notation for the n derivative. Okay. And the first question asks you to find the fourth derivative of the function fx equal to x cubed minus 2x squared plus 4x plus cosine x. So this thing is going to be, you're going to differentiate this guy 4 times. So this will give you f prime x first. So f prime x, you differentiate the first time, you get 3x squared minus 4x plus 4. Okay, and dip cos is negative psi. And for the second derivative, so you get 6x minus 4, and dip psi you get cos x. The third derivative is going to be 6. Okay, dip 4 you get 0, dip cos you get negative psi x. And finally you have the fourth derivative. The fourth derivative of x is going to be, so you see that this guy turned out to be 6 plus psi x, and the fourth derivative turned out to be dip psi equal to cos x. Okay, so this one will be just this 4 derivative. and this one is called the fourth derivative of the function f. Okay, so this one is called the fourth derivative of the function f. The second one, you have y equal to sine x and multiply with square root x plus 2. So in this case, you like to find the fourth derivative of this function. So you gonna just have to find y prime first. So first you're gonna differentiate the first derivative. For the first derivative, you get y prime x, so you dip by using the product rule. So this one is the product rule, okay? And you're gonna differentiate this guy. So you have the first derivative of the second plus the second, which is root x plus 2 derivative of the first. Okay, so for this one will be like this, and after you put in the product rule, you're gonna have to differentiate. So you differentiate root x plus 2, so it's gonna be 1 over 2 root x, and you differentiate sine x, so it's gonna be root x plus 2, and dip side is gonna be cosine x. Okay, so this one is gonna be your y prime. And for the second derivative, you're gonna dip this guy twice. Okay, so you see that the first one turned out to be the quotient. Okay, so you have sine x ddx of sine x over 2 root x, and the second one you have ddx of root x plus 2 times cosine x. So this guy turned out to be product. Okay, so you have product and you have quotient. Let's do them separately. The first one you get to use the quotient rule. So you get the bottom derivative of the top. So dip side you get cos minus the top, which is sine x, derivative of the bottom. So you differentiate to root x, so it's gonna be 2 times 1 over 2 root x. Okay, and it's gonna be everything. Okay, so it's gonna be everything over 2 root x squared. Okay, and then the second one is gonna be the product rule. So it's gonna be the first derivative of the second plus the second, which is cos x, derivative of the first, so it's gonna be 1 over 2 root x. Okay, so in this case you may simplify the total answer to be, okay, so the first one will be just 2 root x times cosine x minus sine x over root x, and everything turned out to be multiplied with 1 over 4x. And the second one is going to be negative of square root x plus 2 times sine x. Okay, and the final one will be cos x over 2 root x. Okay, so I do this one only two example because I just want you to see the definition only first, and then after we study many technique, we're gonna come to the question to find the second derivative anyway, so we not have to do many example right now. The second thing that I will teach you here is gonna be about the important technique in order to find derivative of the function. This guy is called the chain rule. This guy will be used to differentiate the function or the composition of function. Okay, so we use this one to differentiate the composition of function. So let me introduce you a little bit. Before, we have y equal to fx, and you'll be able to differentiate. So you get y prime equal to f prime x. Now we have y equal to f of gx. Okay, and you'll be able to differentiate. So y prime equal to what? This is what we gonna study. Okay, so the chain rule will be here that we're gonna call the function g and the function f. So we have the f of gx. When you have f of gx, we're gonna call this thing the inside function. Okay, so we're gonna call this thing the inside function, and we're gonna call f the outside function. Okay, so we have the function inside and the function outside, and we like to find the derivative of the thing that called composite function. So this guy is a composite function. Okay, and in notation, if you recall from your high school, this thing turned out to be FOG. So the notation that we use is FOG. Okay, so we'll be able to find the derivative of this composite function. And the formula to find the derivative of the composite function turned out to be just you differentiate the outside. Okay, you differentiate the outside, multiply with derivative of the inside. Okay, so you have derivative of outside multiply with derivative of the inside. So normally I'm gonna write just this color. So I highlight only derivative of outside. And what does it mean? It means that if you are looking for f gx prime like this, okay, so you have the thing that sitting inside, which is your gx, and you have the thing that's sitting outside, which is the yellow guy. Okay, so in this case, you're gonna have the derivative of outside, which is your f prime here. Okay, and you have the derivative of the inside, which is your g prime x. So you have your g prime x and derivative of g prime x. Okay, so this one. This guy is called the chain rule. And this one, normally, we're gonna say that this guy is deep inside. Okay, so this one is the chain rule. In another notation, if you have y equal to fu and u equal to gx are both differentiable, then you're gonna have dy dx. So this one is gonna be derivative. Okay, so let me just write down. So this one is the same thing as this one. Okay, this one is the same thing as this one. And you're gonna have f prime gx. F prime gx is gonna turn out to be dy du. And g prime x is du dx. Okay, so they correspond in this way. Why they correspond in this way? Because this one is going to be differentiated. Okay, so in notation, this one may be clearer. So this guy correspond to this guy for sure, because this one is y, and here you get y prime. Y prime turn out to be dy dx. Okay, Clear, right? And this one you differentiate f. However, it's not f prime x, it's f prime gx. And what is gx? Gx is u. So you see that this guy is f prime u. And f prime u is dy du. And g prime x is du dx. So this one is how we have correspond. And why this thing is called the chain rule? Because you may write this thing as y equal to fu, okay? And so y is a function of u, okay? And you have u equal to gx. So it's gonna be a chain in the way that you have, I need other color. So I have y, I have u, I have x. Okay, so y equal to fu, u equal to gx, and you have x. So you be able to differentiate. This guy is dy du, and this guy is du dx. Okay, and you're gonna see that by using the chain rule, you'll be able to get dy dx equal to the product between the yellow guy and the pink guy. Okay, so it's turned out to be the product of the yellow guy and the pink guy here. Okay, so that my dy dx. Okay, so I'm gonna talk about this one later, but let's practice one example. So you have the function fx equal to square root of x cubed plus 1. So in this case, the outside function turned out to be the square root guy. So the square root turned out to be the function outside, and you have x cubed plus 1 is the function that's sitting inside. So in this case, if you want to differentiate the derivative y prime according to the chain rule, so this thing is called the chain rule, it's going to be you need to differentiate the yellow guy. Let me write the solution in a way that you're going to dip the yellow guy. So you dip the yellow guy, okay, and you dip inside. So you dip the yellow guy, so you dip the pink guy, okay? So you dip inside. So you dip the yellow guy and you dip the pink guy. And when you dip the yellow guy, what does it mean? So you dip root x. What is derivative of root x? Derivative of root x, if you recall, is going to be 1. Okay, so let me, okay? So it's going to be 1 over 2 root x. Okay, so you dip the yellow guy. Okay, I not gonna do anything much here, so it's gonna just, I'm not gonna put anything inside, but when you dip the yellow guy, this is what you get for the structure. Okay, so this is dip the yellow guy, this is what you get, and you're gonna multiply by differentiate the inside. The thing that you have for differentiating the inside will be the green one. Okay, so you dip inside. What is dip inside? So you dip x cubed plus 1. So it's going to be multiplied with dip x cubed plus 1 dx. Okay, so this one will be differentiate the inside. Okay, so in this case, you differentiate outside, so you get 1 over 2 root x, 1 over 2 square root, and you differentiate the inside. And then you're gonna have the final answer in terms of 1 over 2. So it's turned out to be 1 over 2 square root of x cubed plus 1. Okay, 1 over 2 square root of x cubed plus 1. and this thing is gonna be here, okay, and you multiply with the differentiate of the inside, so it's gonna be 3x squared, and this guy is the green one, okay. So this one is called the chain rule, okay. This one, for this first example, I do it step by step. For the next one, I'm gonna do it not I'm gonna do this one faster, okay. This one I'm gonna do only one question for slowly to see what's going on, so you have to analyze what is inside, what is outside. However, if you, for doing the next one, I'm gonna do this one faster. For the next one, the thing that we have is going to be, you like to find derivative of sine x squared, okay, and derivative of sine of x squared, okay. So for this one, it's pretty simple that you have the outside is x squared and you have the inside is sine x. So you basically dip the inside one, so it's gonna be what? It's gonna be 2, okay, and you don't care, it's gonna be 2 and 2 minus 1, so you have the power function. This one is your derivative of the yellow guy, so this is the derivative of your yellow guy, and you have to multiply by differentiate inside, so you're gonna multiply by dip sine x, so this is the derivative of the inside. So you get 2 sine x, okay, and you dip sine, you get cos x, okay, so you dip sine, you get cos x. So this one will be your final answer, okay. So let me like circle the green one for you. So this one, okay, and this one is your derivative, okay. And you have here, you put sine x, so it's gonna be, like I said, it's gonna be sine of x like this, okay. So it's gonna be this one. You see the structure, you dip the yellow guy, okay, you dip the yellow guy, derivative turn out to be the yellow one that I highlighted, and you have sine x inside parentheses. Now let's do sine of x squared. Sine of x squared, you see that the yellow guy turned out to be sine x. Okay, so the yellow guy turned out to be sine x, and the pink guy turned out to be x squared. So I would want you to compare this one. Okay, this is the reason why I do this one step by step for you. So you would get what? You get to dip outside. Outside is going to be dip side, so you get cos, okay, of parentheses like this, okay, and you're gonna have to differentiate inside, so you differentiate x squared, so this guy is differentiate the pink guy, and this one is a cosine of the pink guy, and this is the derivative of the yellow, okay. So derivative of the yellow turned out to be like a cos x, okay. So you dip this guy, is gonna turn out to be cos x, and then you're gonna just write down, so it's gonna be cos, and the pink guy turned out to be sine x, okay. So it's gonna, oh sorry, x squared, yeah. So you have cos of x squared, okay, and then what? And then you dip x squared, so you would get 2x, okay. So this one will be derivative that you have. Okay, so you see the difference between these two composition of function. One is going to be sine x squared, another one is going to be sine of x squared. The next one is going to be e to the 10x. Okay, so e to the 10x, let me use other color. So you see the function inside and the function outside. The function inside turned out to be 10x. Okay, so it's e to the 10x. So the function outside is going to be e. E is going to be the dominate outside. So it's going to be e to the 10x. So this one, when you differentiate, it's going to be e, okay? So it's going to be e to the function, okay? So this one is to the pink guy, okay? So e to the pink guy, and you dip the pink guy, so it's d dx of 10x. So in this case, it's going to be e to the 10x. Okay, so it's going to be e to the 10x. And dip 10, you would get secant square. Okay, so you get 10 secant square like this. The next one, you get dip 10 e to the x. So for this one, the outside turn out to be 10x and the inside turn out to be e to the x. So you dip outside, okay? So you dip outside, it's gonna be 10 prime of the pink guy, okay? So you can write this one is 10 prime of the pink guy, and you dip the pink guy, okay? So if you write this one, okay, it's gonna be like that. And you dip 10, you would get secant square of the pink guy. Okay, so you have the secant square of the pink guy, and you dip e to the x, so you get e to the x. So in this case, the final answer would be secant square e to the x multiplied with e to the x. Okay, and this one will be derivative of e to the x. Okay, so this is how we have derivative by using the chain rule. The next one will be you have the dx of 1 over 2 plus sec x. Okay, so in this case, the inside and the outside will be, the inside is going to be, if you put parentheses here, if you put parentheses here, you're going to see that this one become 1 over 2 of something like this. Okay, and so in this case, the outside turn out to be 1 over, okay, so this one is gonna be the yellow guy. Okay, so this function, and the inside turn out to be the 2 plus sec x. Okay, so this one will be the outside is 1 over. When you dip 1 over, this one is that parenthesis to the negative 1. Okay, and you dip 1 over. I taught you that when you dx of 1 over x, so this guy is going to be negative 1 over x squared. Please memorize this one. Okay, this is what I told you before. So in this case, it's going to be negative 1 over square. Okay, so this one is dip outside. And you multiply with derivative of the inside. So you derivative of 2 plus sec x. Okay, so you have derivative of 2 plus sec x. So you see that this is the guy here, and you're gonna have negative 1 over. Okay, so you're gonna get 1 over 2 plus sec x square, and you dip 2 plus sec x. So you dip 2 plus sec x is gonna be dip 2, you get 0, dip sec, you get sec x, 10x. Okay, so it's gonna be like this. So in this case, this guy will be sec x, 10x over 2 plus sec x square. Okay, and this is your final answer. Okay, so this is how we differentiate like a quotient. However, it's not quotient, it's gonna be just 1 over gx. Okay, it's like 1 over gx. Another thing will be you have sec. Okay, sec of 2 plus 1 over x. So in this case, sec will be function outside, and 2 plus 1 over x will be the function inside. So you differentiate sec. It's gonna be sec something tan something. Okay, so it's gonna be sec something tan something, and you're gonna have to dx of that thing. Okay, so it's gonna be sec the pink guy, tan the pink guy, and ddx of the pink guy. So in this case, it will be, let me use other color. So it will be sec 2 plus 1 over x tan 2 plus 1 over x. Okay, and you multiply with derivative of 2 plus 1 over x. Okay, so you multiply with derivative of 2 plus 1 over x. What is derivative of 2 plus 1 over x? Derivative of 2 plus 1 over x is going to be negative 1 over x squared that I already asked you to memorize. Okay, so for this one, you dip 2, you get 0. You dip 1 over x, you get negative 1 over x squared. And this will be your final answer. Okay, so this will be, you may write this one nicer. So it's going to be negative of sec 2 plus 1 over x tan 2 plus 1 over x, and you have 1 over x squared, like this. Okay, so this one is derivative of sec 2 plus 1 over x. Okay, so the thing that we always have is gonna turn out to be the power rule combined with the chain rule. When you have the power rule combined with the chain rule, you have fx equal to x to the r. This one turned out to be the outside, and you have gx inside. So you have f or gx, which is turned out to be gx to the r. So if I highlight yellow for you, you have the power outside and you have the gx inside. So you're gonna dip the yellow guy. When you dip the yellow guy, it's gonna turn out to be r come down and everything to the r minus 1, and you have gx multiplied with g prime x like this. Okay, and this guy turned out to be dip inside. Okay, and this one is called the chain rule combined with the power rule. Okay, so power rule combined with the chain rule that I said here. So you may memorize this one in another way also. So it's going to be dip u to the r. Okay, r is outside and u is inside. So it's going to be r come down, u to the r minus 1, and you dip u. Okay, so this one is also dip inside. Okay, so this is what we have so far. So you see, you want to find derivative of this guy. So this guy will be outside is the power 6, and the inside turn out to be this 10 minus x to the 4th. So you get y prime equal to 6, 10 minus x to the 4th over psi x. Okay, so this one is going to be 6 minus 1. So you have this guy, okay, inside. And you have to differentiate inside. So it's going to be d dx of 10 minus x to the 4th over psi x. So in this case, you get 6, and you have 10 minus x to the 4th over psi x. to the fifth, and u ddx of 10 minus x to the fourth over sine x. So in this case, you need to differentiate by using the quotient rule. Okay, so this one, you're going to use the quotient rule. So in this case, it's going to be the bottom, which is sine x, derivative of the top, which is negative 4x cubed, minus the top, okay, derivative of the bottom, which is cos x, and everything will be over the bottom square. So it's going to be over sine x square, okay. So in this case, this one is your final answer, and this guy, you obtain it from using the quotient rule. Okay, so this is how we have the final answer for this guy. Another one, you're gonna have the product. Okay, so this one is the product. And you see that it's gonna be, you have to put this one in terms of the product rule first. So it's gonna be the first derivative of the second plus the second derivative of the first. So in this case, you're gonna have, okay, so, okay, wish me luck. do I have enough space? So this guy is gonna be 2x plus 5 to the pi, and you dip x cubed plus 3x minus 4 to the fourth. It's gonna be 4 come down, and you have x cubed plus 3x minus 4 to the third, and you differentiate the inside, so you get 3x plus 3x squared plus 3. Okay, so this one is deep inside. Let me underline this one a little bit. This guy is deep inside. Okay, and you're gonna have another term, which is x cubed plus 3x minus 1 to the fourth, and you dip 2x plus 5 to the pi, so you have pi come down, and dx of 2x plus 5 to the pi minus 1, and you differentiate, so you get 2, so you differentiate the inside. Okay, so this guy is div 2x plus 5. Okay, so this is how we have the derivative by using the chain rule combined with the product rule. The next page gonna give you in the way that it's gonna combine the symbolic differentiation together with the chain rule. Okay, so you have fx equal to pi plus gx to the 8. So in this case, you have the outside and you have the inside. Okay, so you have the outside and you have the inside, and you would want to find f prime 2, where g2 equal to 3 and g prime 2 equal to negative 4. So in this case, let's first find f prime x. So you have f prime x equal to, okay, so you see that it's gonna 8 come down, pi plus gx to the 7. Okay, so it's gonna be this one, and don't forget to differentiate the inside. Okay, so you differentiate the inside, so this guy will be 8 pi plus gx to the 7, and dip pi plus gx, so you get 0 plus g prime x. Okay, and you have f prime 2 will be 8 pi plus g2 to the 7, and you have g prime 2, so you get 8 pi plus g2 is 3, okay, to the 7, and g prime 2 equal to negative 4. Okay, so you have g prime 2 equal to negative 4. Okay, so you plug everything in, and so far we get negative 32 pi plus 3 to the 7. Okay, so this one is your f prime 2. The next one, you have y equal to the capital F of x squared minus 1 over root x. Okay, so for this one, you see the inside is x squared minus 1 over root x, and you have your outside, which is your function f, the capital F. You like to find y prime at x equal to 1, okay, and you know f prime 0 equal to 2. Okay, so let's differentiate this one. So you get y prime, and you dip the yellow guy. Okay, so you dip the yellow guy of the whole pink guy. Okay, so you dip the yellow guy with the whole pink guy like this. I don't have to write it down. And you differentiate the pink guy. So it's going to be d dx of the pink guy. So you get x squared. And what is 1 over root x? 1 over root x turn out to be x to the negative 1/2. Okay, I write it this way because it's going to be easier to differentiate. And you see that it's going to be f prime, okay, and you dip, and the pink guy you copy, so it's going to be 1 over root x, okay, and you differentiate. So you see that you need to differentiate the inside here, so you're going to get 2x, okay, and you have plus 1/2 x to the negative 3/2. Okay, so this one is your derivative. Okay, and so you would get y prime equal to f prime. Okay, what is you need? You need y prime at x equal to 1. Okay, so I'm gonna have to write y prime 1. Okay, so y prime 1 is mean you're gonna plug in x equal to 1. So it's gonna be f prime 1 square minus 1 over root 1. Okay, and you have multiply with 2 times 1 plus 1/2 times 1 to the negative 3/2. Okay, so in this case it's going to be f prime 0. Okay, multiply with the numbers that you have. This one is 2 plus 1/2, and f prime 0 equal to what? Equal to 2. Okay, so this one come from f prime 0 equal to 2, and you're gonna multiply with 5 over 2. You multiply with 5 over 2, so basically you would get 5 for final answer. For the last one for this page, you like to find the tangent line. You like to find the tangent line, so you need slope. So the slope in this case turned out to be derivative at 0, okay? And you need slope and 1 point. Okay, so you need slope and 1 point. Let's find the point first. For the point, you have y at 0, so it's gonna be e to the 0 minus 3 times 0, okay, plus sec 0 square, okay. So in this case, it's gonna be what? It's gonna be 1 minus 3, okay, so it's gonna be 1 minus, not 3, so it's gonna be 1 plus 1 square, so it's gonna be 4, okay, so the point turned out to be y0 equal to 4, so it's gonna be the point 0, 4, okay, so the point turned out to be 0, 4. Let me put point here. Okay, so you have the point 0, 4, and you're gonna have x equal to, you're gonna differentiate, so you get y prime, okay, so it's gonna be 2 come down, e to the x minus 3x plus sec x, okay, and you dip inside, so you get e to the x, dip 3x, so you get minus 3, okay, and dip sec, you would get sec 10 sec x 10x, okay, so that my derivative, and then you plug in y prime 0, y prime 0 is going to be 2 e to the 0 minus 3 times 0 plus 6 0, okay, and you have e to the x, so it's going to be e to the 0 minus 3 plus 6 0 10 0, okay, so in this case this guy will be 2, and the second one would be again 2, and the third one will be negative 3 plus 1, so it's going to be negative 2, so it's going to be negative 8, okay, so the slope equal to negative 8 in this case. So you're going to use point slope form, okay, so the tangent line is, okay, so the tangent line turned out to be y minus 4 equal to negative 8 x minus 0, okay, and this guy will be y equal to negative 8x plus 4 for your final answer, okay, so you just use point slope form here, and the slope that we have is negative 8, and you put it here, okay, and the point is 0, 4. Now we're gonna derive another important formula. Okay, it's gonna be differentiate of the exponential function of any base. So it's gonna be, you have a greater than 0, and you're gonna have a not equal to 1. So we may write a equal to e to the log a. Okay, so this one is the property of the exponential function and the log. The thing that I want to explain is going to be when you see e and log together like this, they will cancel each other to give you just a. Okay, when you have e raised to the log like this, it will cancel each other and it's going to give you just a. So a can be written as something like this, and then you just raise everything to the x. Okay, so you just raise everything to the x, so you would get a to the x equal to e to the log a times x. Okay, so a to the x equal to e to the log a times x. So you differentiate both sides. So you differentiate a to the x, so it's going to be differentiate e to the log a times x. So this is what we get. And this guy is going to be differentiate the function inside. So this one I'm going to highlight the pink one. Okay, so this one is the pink one. And the yellow one turned out to be e. So when you differentiate e to the log a, so it's going to be the yellow one. Okay, so you dip e is going to be e to the log a. So this guy is going to stay the same. Okay, or let me write down the formula for you to see what's going on easier. So when you differentiate e to the u, it's going to be e to the u, which is the yellow function outside. So it's going to be e and u. So it's going to be u and e like this. And don't forget to differentiate inside. So it's going to be the dx of the pink one. So it's going to be the u dx. Okay. So in this case, you have to differentiate the pink one. So you dip log a x. Okay. So in this case, you get what? It's going to be e to the log a. So this one, I just copy this term. I just copy this term and you dip log ax. Okay. So you dip log ax and my log a here is just constant. Okay, so it's going to be just constant. So you basically be able to pull it outside, and the thing that you have to differentiate turn out to be dip x, and dip x turn out to be equal to 1. Okay, so it's going to be e to the log ax multiplied with log a, okay, which is the constant. Let me constant. And so this guy, which is the pink one here, you see. So you see that, let me use other color. Let me use the blue one instead. So you see that this guy and this guy turn out to be the same. Okay, e to the log ax and a to the x turn out to be the same. So it's going to be a to the x log a multiplied by log a. So we're going to have the formula for differentiating dip a to the x. Okay, dip a to the x is gonna turn out to be a to the x log a. Okay, so this is another important formula. So we have before, okay, so we have dip e to the u. So can we write down in terms of dip a to the u? So if I ask you what is dip a to the function u, so in this case, you see that it's going to be the whole thing. So it's going to be a to the u log a, and you dip the function inside. So it's going to be du dx. Okay, so this one is a dip function inside. Okay, and the dip inside is this term. Okay, so this one is dip inside. Okay. So let's first do dip 2 to the side x. Dip 2 to the side x for this one is going to be 2 to the side x. Okay, log 2, log 2, and dx of psi x. Why did I have that? Because in this case, you see that you have a equal to 2 and u equal to psi x, and I just apply this formula. Okay, so you have u equal to psi x. This guy is a function on top. Okay, and you see that it's going to be the base equal to 2 in this case, and it's going to be log 2, and you have to dip the function inside. Okay, and so you would get 2 to the psi x log 2, and dip psi is cos. Okay, so this one you get that. The next one, you have 1 over 3 to the x plus x to the third. So in this case, you're going to have u, which is something down here. Okay, so you differentiate this guy is going to be 1 over u square. Okay, and you have du dx. Okay, so this one is the derivative of 1 over u. So it's going to be negative 1 over 3 to the x plus x cubed square, and you have to differentiate the inside, which is 3 to the x plus x cubed. Okay, So in this case, this guy, you get negative 1 over 3 to the x plus x cubed square. And dip 3 to the x is going to be 3 to the x log 3 plus 3x squared. Okay, so this one, let me do this one separately. So this one is the green one and this one is the red one. Okay, so you have 3 to the x and x cubed. Okay, so we have a name for something like this. 3 to the x is called exponential function. Okay, and x to the third like this is called power function. Okay, so this guy is called power function and exponential function. Okay, the most important thing, like I said before, you need to memorize dip 1 over u is negative 1 over u square. Okay, so it's negative 1 over u square. Last one. So last one is going to be chain rule. However, we have the inside kind of more complicated. So you see that you're going to have the function inside, outside. So the outside one turned out to be the power function, okay, the 12, okay, and the inside one turned out to begin with psi x, okay, and you have another inside one which is root x. So this one is the composition of the function that is more than two functions. It's going to turn out to be three functions here. So you have the first function, okay, the second function, and the third function. Okay, so when you differentiate this guy, so you get y prime equal to, so you differentiate this one, so you get 12, and you have psi root x raised to the 11 one. So this take care the yellow function. Okay, so this just take care the yellow function. So it's going to be the very outside. And now you're going to have to multiply with derivative of the inside parenthesis. The parenthesis in this case is psi root x. So it's going to be d dx of psi root x. And you see that this guy is the pink guy and the blue guy. And you have 12 and you have psi root x to the 11. And dip psi, you get cos root x. Okay, so this one take care derivative of the pink guy. Okay, so we take care derivative of the pink guy. However, we have to also take care derivative of the blue guy. Okay, so you see that it's going to turn out to be 3 steps in this case. And finally, we take care derivative of the last one, which is derivative of root x. So it's going to be psi root x to the 11 cos root x. Okay, and you have d dx of root x is 1 over 2 root x. Okay, so this one like this. So in this case, this is the blue one, this is the pink one, and this is the yellow one. Okay, so it's gonna be taken care separately. So let me write this one as this is the first, this is the second, and this one give you the third inside. Okay, so we take care of them step by step. The next one, we do the same thing. I'm gonna do this one faster. So you see that you have the outside one, you have the second one, which is 3, and the inside one turn out to be x squared. So in this case, you indicate this one as the first, the second, and the third one. Okay, so in this case, you would get y prime equal to, I'm gonna do 3 function. Okay, follow me. Dip cot is negative cosec square, and you just copy everything. Okay, so this one is my first, and I'm gonna multiply with my second. Your second turned out to be dip 3 to the x square. Okay, so this 3 to the x square. So in this case, you get negative cosec square 3 to the x square. Just copy, and you differentiate 3 to the x square. So it's going to be 3 to the u. Okay, so it's going to be 3 to the u log 3, and you dip x square. Dip x square, you get 2x. Okay, so this one is dip x square. And this one will take care first, second, and third respectively. Okay, so this one will be just this question. Okay, not that hard to do. Okay, I believe that. The next one, you have y equal to sec square. Okay, so you see that the first function in this case is going to be square function. Okay, so the square will be outside because what? Why don't you see? Why it's not secant? It's not secant because if you rewrite this thing, it's going to be 6 to the x plus pi square, and square will be the most outside one. So in this case, this is how I see this function. And you have the second one, which is sec, and the inside one will be pi square. Okay, so this is what you should see first, second, and third respectively. And you see that it's going to be 2 come down, and you have sec 6 to the x plus pi square, and you're gonna have to dipsec 6 to the x plus pi square. So you dipsec, you get sec 10, right? So it's gonna be 2 sec 6 to the x plus pi square, and you dipsec, you get sec. Okay, don't forget to copy everything. Okay, don't just say sec 10. Okay, it's going to be sec of the whole parenthesis, 10 of the whole parenthesis. Okay, and you multiply by derivative of the inside. Okay, derivative of the inside turned out to be 6 to the x log 6 plus 0. Okay, so this one is derivative of the inside. So dip 6 to the x plus pi square. Okay, so this is what we have. Last one. You have y equal to e to the cosine x. So this one outside. Okay, and the second one will be cos, and the third one will be 4 to the x. So this guy will be y prime equal to e to the cos 4 to the x, and you don't forget to dip cos of 4 to the x. Okay, and so you're gonna get e to the cos of 4 to the x, and you're gonna dip cos, you get negative sine of 4 to the x, and dip 4 to the x is gonna be 4 to the x log 4. Okay, so this one will be your final answer. So this one will be your derivative of the blue guy. Okay, so this one is the blue guy, and you don't forget to differentiate the blue guy. Okay, so this is the whole thing for the chain rule. You have to be able to find derivative by using the chain rule. It's going to be the very important technique in order to find derivative of a given function. Okay, if you not quite understand, rewatch this script again. Okay, so you have to be able to manage the chain rule, and you have to be able to differentiate using the chain rule. It will be the most important rule to use in calculus. Okay, and every function after today will use the chain rule to differentiate it. Okay, so that's all for this one.